Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. This is a review of chapter 6. Let us first review the formulas in this chapter that we studied. Simple interest, I equals PRT, the principal, times the annual interest rate, times the number of years. And the future value of a simple interest is the principal plus the interest. While for compound interest, we have periodic compounding, monthly, daily, weekly, and so on. So I is equal to R over M, how many number compounded per year. Monthly, for example, we divide by 12. R is the annual rate, and T is the number of years. And if it is continuous compounding, then the future value is the principal times e to the power RT. Annual percentage yield. This is the formula of the annual percentage yield. And if you remember, we take P here 1 and T 1. So it is 1 plus R over M to the power M. And we subtract 1, minus 1. This is the annual percentage yield in case of periodic compounding. And in case of continuous compounding, also P1, T1, so ER minus 1. And these are the formulas for the future values of annuities, the future value of ordinary annuity, future value of annuity due. And the only difference is we multiply here by 1 plus I. And the present values of annuities. This is present value of ordinary annuity, annuity due, and the only difference is we multiply by 1 plus I. And notice that this is 1 plus I to the power n minus 1, while this is 1 minus 1 plus I to the power negative n. So let us solve some exercises about all of these formulas as a review of chapter 6. If 8,000 is borrowed at 12% simple interest, so simple interest, so 12%, this is R, and 8,000 is borrowed, so this is the principal. For 3 years, this is the time. What is the future value of the loan at the end of 3 years? So he wants the future value S, which is the principal plus the interest. And the principal is 8,000 and the interest is PRT. So the principal times R, which is 0.12, times T, which is 3. And if you multiply this using the calculator, you get $10,880. How much summer earnings must a college student deposit on August 31 to have 3,000 for tuition and fees? So this is a future value. Okay, let us call it S. On December 31. Between August 31 and December 31, 9, 10, 11, 12, 4 months. 4 months of the same year. So let us write 4 months. If the investment earns 6% simple interest, so this is R, and T here would be 4 months over 12, because if you remember, T has to be in years. So it's 1 over 3. S, that's what we have. So how much summer earnings must a college students deposit on this date? So he's asking about P, that's the principal. So what is the principal needed to have $3,000 on this date? So we know that S equals P plus I So S is, let me first, I have S equals P plus I. And you know I is PRT. So I can take P as a common factor and write it 1 plus RT. So S is the 3000 equals to P, which we need to find, times 1 plus RT. Well, this is T. What is R? 0.06. So 1 plus 0.06 times 1 over 3. So P would be the division of 3000 over this amount, which if you add, it is 1.02. So the answer is $2,941.18. This is the amount he needs now to put in the bank as a deposit to get 3,000 after 4 months under these conditions. An investment is made at 8% compounded quarterly 4 times a year for 10 years. Find the number of periods. Well, the number of periods 4 times a year times 10 years, so that's 40. Find the interest rates per period. The interest rate per period is 8% divided by 4 times a year, so that's 0.02. Write the formula for the future value of a compound interest investment if interest is compounded periodically. Okay, we have just seen this formula that S equals to P1 plus R over M, or you can call it I to the power M times T, or you can call it N. So you can write it like this if you like. Continuously, S is PERT. So that's the formula for compounded continuously. If $1,000 is invested for 4 years, T, okay, at 8% R compounded quarterly 4 times, how much interest will be earned? How much interest he is asking about. So, well, the interest is the future value minus the principal, okay? And the future value is using the formula 1000, that's the principal, that's the future value. We'll use this formula, okay, times 1 plus R over M, 0.08 over 4 to the power M times T, 4 times 4, 16, minus the 1000, which is the principal. And if you calculate this by the calculator, you will find that the answer is $372.79. That's the interest. How much must one invest now to have 18,000? So this is the future value in 4 years if the investment earns 5.4 compounded monthly. If you want, I can write it as I here interest per period, it is 0.05 over 12, and you can find it or keep it. And N is M times T, so 4 years compounded monthly times 12, that's 48. And the formula, how much must one invest now? So the future value is there. And the principal is needed times 1 plus I, which is point over 12 times 48. And P would be the division of 18,000 over this amount. And the answer is $14,510.26. What is the future value if 1,000 is invested? So this is P for 6 years, that's T, that's R continuously. So future value is S equals P E R T. And just put it in the calculator and you will find that the answer is $1,616.07. A couple received an inheritance and plan to invest some of it for their grandchild's college education. How much must they invest if they want the fund to have 100,000 after 15 years? So this is the future value. And their investment earns 10.31 compounded continuously. So P is missing. That's what we need to find. E to the power R times T. And then P would be equals 100,000 over E to this power. And if you put it in the calculator, you will find that the answer is 21,299.21 dollars. So if they invest this amount now, we will have 100,000 in 15 years under these conditions. If 15,000 is invested, so this is P at 6% compounded quarterly 4 times a year, how long? Okay, he is asking about T. How long will it be before it grows to 25,000? So 25,000 is the future value, and 15,000 is the principal. And we use the formula 1 plus 0.06, which is R, over 4 to the power. We have 4 quarters times T. Okay, we can find the answer number of quarters of or number of years. If you want to find the number of quarters, just the number of periods would be n. And now we start by dividing 25,000 by 15,000. And this will give you 5 over 3. And this would be 1.015 to the power n. And as usual, we apply ln to both sides. And because of that, we can take n here now. And then n would be equal to ln 5 over 3 over ln 1.015. And the answer would be 34.31. So how long we need, it needs 35 quarters. Okay, 35 quarters. After 35 quarters, the money will grow to 25,000. If an initial investment of 35,000 grows to 257,000. So this is P, and it grows to this in 15 years. What annual interest rate, so R is missing here, compounded continuously was earned? Okay, so S is 257 equals to P, which is 35,000, e to the power r is missing, and t is 15. So first step, we divide by 350 thousandths. And when we divide by 350 thousandths, we get 257 over 35. Okay. And now we apply len to both sides. And we know that len ex is equal to x. So if I put len here, it will be cancelled with e, and I'll have just 15 times r. So r would be len this number over 15. And if I use the calculator will say 0.1329. So R is 13.29%. That's the annual interest rate. What is the annual percentage yield of this investment? Well, the annual percentage yield by definition is, or by the formula, is e to the power r minus 1. And r is 0.1309. So we just put it in the calculator. This is not 0, this is 2. And the answer would be 0.1421. So the annual percentage yield is 14.21%. So that's the annual percentage yield. Find the annual percentage yield equivalent to a nominal rate. Nominal means annual, okay? A nominal rate of 7.2% compounded quarterly. Oh, there is another part here missing. I think part B is compounded continuously. Okay, so part A, the annual percentage yield when compounded quarterly, is the formula is 1 plus r to the power m to the power m minus 1 from here. So it is 1 plus r is 0.072 over m quarterly, so that's 4, to the power m, that's 4, minus 1. And if you use the calculator and evaluate, you will find that 0.07397. This means that the annual percentage yield is 7.4%. Okay, while in part B, compounded continuously, it is e to the power r minus 1. And by the calculator, this is 0.074655. So it is 7.47%. Okay, so the annual percentage yield of compounded continuously is of course better than the annual percentage yield of compounded quarterly. Find the future value of an annuity of 800. So this is R, paid at the end. So this is ordinary annuity of every 6 months. That's twice a year for 10 years. So N is 2 times 20, 2 times 10, 20. And the interest per period is 0.12 semi-annually, so over 2. So it is 0.0 6. And we need to find the future value. The future value is equal to R times n times 1 plus I, so 1.06 to the power n, okay, 20, 1 plus I to the power n minus 1 over I, because it is ordinary annuity. And the answer would be, if you use the calculator, to 29,428.47. How much would have to be invested at the end of each year, 6% compounded annually, to pay off a debt of 80,000 in 10 years? So there is a debt 80,000, okay? And so that's the future value given. And in 10 years, we need to pay this debt. So how much would have to be invested after the end of each year now? So what would be the deposits now? That's R, okay, at the end of each year. So this is an ordinary annuity. And 1 plus I would be 1.06 to the power n is the number of periods here, minus 1 over I, which is 0.06. And this is an ordinary annuity, so we can divide 80,000 by this number, and the answer, if you use the calculator, would be 6,069.44. So if you put this amount, if you deposit at the end of each year for 10 years, you will get 80,000 after 10 years under these conditions. Find the future value of an annuity due of 800 paid at the beginning of every 6 months. So this is R twice a year, 10 years, so N is 20, interest rate 12, so I is 0.12 twice a year, 0.06. S would be, S due in this case would be 800 times 1 plus I to the power 20 minus 1 over I. And because it is annuity due, we need to multiply by 1.06 or 1 plus I. And if you use the calculator, the answer would be 331,194.18. So this would be the future value of this annuity. A company wants to have 250,000 available in 4.5 years. 4.5. So this is future value. Okay, this is a future value. The lump sum is in the future for new construction. How much must be deposited at the beginning of each quarter? Beginning of each quarter, this is annuity due. To reach this goal, if the investment earns 10.2 compounded quarterly, so I is 0.102 over 4, and this is 0.0255 if you find by the calculator, okay? And in the number of periods, 4.5 times 4, because quarterly, and this is 18. And now the future value is given 250,000 of this annuity. And R is what we need to find the deposits times 1 plus I, okay, to the power n minus 1 over I, and this is annuity due. So we multiply by 1.0255. And we divide 250,000 by all of this number to get R. And we will find that if you put it in the calculator, that R is 10,841.24. If 1,200 is deposited, so this is R, at the end of each quarter, so this is ordinary annuity, in an account that earns 7.2, so I is, we divide 0.072 over 4, and we will find that the answer is 0.018. How long will it be until the account? So N is required worth. So this is the future value. So we have 60,000 equals 120. Okay, this is ordinary uh, annuity. So times 1 plus I, yes, to the power n minus 1 over I. And we need to find n because n is missing. So we start by dividing 60,000 by 100 by 1,200 and then multiply by 0.018 or divide 1,200 by 0.018 and then divide 60,000 by this number. So you'll find that 0.9 is equal to 1.018n minus 1. And we take 1 to the other side. So we'll have 1.018 to the power n equals 1.9. And then we apply len to both sides and we take n out. So we will have n times len 1.018 equals len 1.9. And then n would be len 1.9 over len 1.0118. And if you use the calculator, the answer is 35.98. So how long will it be? It will be 36 quarters, or we will need 36 quarters. What lump sum would have to be invested at, so we need to invest this lump sum at 9% compounded semi-annually. So I is 0.09 over 2, and that's 0.045 for 10 years. So n is 2 times 10, that's 20. To provide an annuity of 10,000 at the end of each half year for 10 years. So what lump sum would have to be invested? This is the lump sum we need now. Okay, so this is the present value of annuity that it will give us 10,000 at the end of each half year for 10 years. Okay, so AN is missing, and at the end this is an ordinary annuity. So R, the payments in this case are 10,000 times the formula for present value of annuity is 1 minus 1 plus I to the power negative n, okay, over I. And if you use the calculator, you will find that the answer is 130,079.36 dollars. This is the sum we need now to give us 10,000 each half year for 10 years. A couple wants to set up an annuity that will provide 6 monthly payments of 3,000 while they take an extended cruise. Good. So they want an annuity. They need some money to put now, and this money should provide for them 6 months payments. Each month they receive 3,000 for their cruise. How much of a 15,000 inheritance? Okay, this is an amount they inherited, and they are thinking how much of this amount they need for this plan must be set aside if they plan to leave in 5 years. They will need this money, this six payments. They will need it in 5 years. So these are six payments, okay? And we need the present value. Must be and want the first payment before they leave. If they are taking the first payment before they leave, so this is an annuity due. Assume that money is worth 7.8 compounded monthly. Will I is 0.078 over 12. And I is the same in case of future or present value of an annuity. So this is an easy to find. Let us find it and think of this nice problem. Now, the question is, we need the present value of an annuity, this annuity. I'll find the present value of this annuity. Well, the present value is for the formula R, which is 3,000, this is R, times 1 minus 1 plus I to the power negative n. We are dealing monthly here, monthly, and they need it for 6 months. So n is 6, okay, 6 periods over 0.0065. And this is, they need it before the leave, the first payment. So this is an annuity due. So I need to multiply by 1.0065. Use the calculator to evaluate this, and the answer would be 17,711.88. Well, this is what they need, okay? What they need, but they need this amount in 5 years, okay? They need it in 5 years. Not now, not tomorrow. They need it in 5 years. So what would happen now? They inherited $15,000. So they will put this amount of money, 15,000, in the bank for 5 years. So what would be the future value of this amount in 5 years? You can find this, but is it important? Well, for me, it's not important. I just want to know how much of the 15,000 they must set aside. Okay, so this is the amount they need. 17. This is the amount they need, but they need it after 5 years. So there is a principle, a part of 15,000. Okay, they will put in the bank that's compounded monthly. So we use the compounded interest formula. So 1 plus I, which is 0.0065 to the power n. Now, what is n? We are dealing monthly, compounded monthly. 5 years. 5 years times 12 months, that's 60. Okay, so we need to know the amount of money they should put now in the bank, and after 5 years they will get 17,711.88, because this is what they need to start an annuity to give them what they need for the cruise, 3,000 per month, monthly. So that's easy. You can divide this by this, and you find that if you use the calculator, P is $12,007.09. So they need this amount of money. So they must set aside this amount of money. Uh, they need this amount. They should put it now in the bank. After 5 years, it will give them 17,711,000. Then they put it as a present value of an annuity, and they take 3,000 each 6 months. A recent college graduate's gift from her uh, grandparents is $20,000. Okay, so this is a gift, and she has it now. She has the $20,000. How much will this provide at the end, ordinary annuity, of each month for the next 12 months? So N is 12 because everything is in months, while the graduate travels. Assume that money is worth 6.6 compounded monthly. So let us find I, divide 0.066 by 12, and by the calculator, this is equal to 0.0055. Okay, so what do we need? She has a gift, so this money is available now. Okay, so that's the present value of an annuity. And she needs payments for the next 10 months. She needs some payments, annuity. Okay, so this is what we need to find are the payments. And this is a present value of annuity. So we need the formula 1 minus 1 plus I, so 1.0055 to the power negative n, which is 12, negative 12 over I. And this is ordinary annuity. So that's it. And we can solve this for R, dividing 20,000 by this number. And the answer, if I use the calculator, would be 1,726.85. An IRA, individual retirement account, of $250,000 is rolled into an annuity. So we have this amount, and we will put it in annuity that pays a retired couple at the beginning, annuity due, of each quarter 4 times a year for the next 20 years. So N is 80. 4 times 20, immediately 80. And so this is, we have it. So this is the present value of an annuity. And we need to know uh, if the annuity earns 6 point compounded, how much will the couple receive at each quarter? So we need to find R. 1 minus 1 plus I. What is I? 0.062 quarterly. So we divide by 4 and we get 0.0155 if I use the calculator. So 1 plus I is 1.0155 to the power negative n, which is 80, over 0.0155. And he said what? At the beginning. So it's annuity due. So we multiply by 1.0155, 1 plus I. And we can use the calculator, divide this number by this number to get R, the payment, and R would be 5,390.85. $0.77. A retirement account that earns 6.8 compounded semi-annually. So immediately, what is I? Dividing this by 2, I is 0.034. Compounded semi-annually contains, so the account contains this amount. So this is the present value of the annuity. It is there already. How long? Oh, he is asking about N. Can 40,000 be withdrawn? So 40,000 are the payments, okay? Times 1 minus 1 plus I to the power negative N, because N is needed, over 0.034, which is I. Is it annuity due or at the end of? So it's an ordinary annuity. So how to solve this? We start by dividing both sides by 40,000, okay, and then multiply by 0.034 and applying uh, ln to both sides after taking one to the other side. Please do it. We have done a question about it earlier to solve for n and to make sure that n is 16.03 half years. Well, 0.03, it is approximately 16, so you can say approximately 8 years. After approximately 8 years, the balance would be 0. After 8 years, balance would be, it will not be 0 exactly, less than some very few dollars, because 0.03. The last question, and please pay attention to this question because it's a very nice one. 3 years from now, a couple plan to spend 4 months traveling in China, Japan, and Southeast Asia. So after 3 years, they want to spend 4 months traveling. When they take their trip, they would like to withdraw. So these are payments they need after 3 years at the beginning, annuity due of each month monthly, to cover 4 months, okay, to cover their expenses for that month. Good. So we need a present value of this annuity. AN due is needed. All right. Starting now, how much must they deposit? So they are thinking of this. To get this present annuity, how much must they deposit at the beginning of each month from now? Because they have 3 years to plan. Okay. So in these 3 years, they need to put a deposit monthly in an account that will give them, at the end of this account, they will have AN. So now the money they are going to deposit, this is R, okay? And this is a deposit, you know. So this is an annuity, and we need the future value of this annuity. We can find the future, we know the future value of this annuity. It would be AN. The future value would be AN, the present value. So of the other annuity, there are 2 annuities in this question. So let me find first the present value of the annuity they need after 3 years. Okay, what is R? 10,000. They want to the account to pay them. These are the payments to withdraw 10,000. 1 times 1 minus 1 plus I. So what is I in always both cases? It is 0.066 over monthly we are talking monthly, so this is 0.0055. So 0.0055 negative. How many months? 4 months. Okay, 4 months. They need it only for 4 months, the trip. So 1 minus 1 plus I to the power negative n over I. And this is an annuity due, okay, at the beginning. They need it at the beginning of each month. So times 1.0055. And if you put this in the calculator, you get $39,673. So this is the amount they need after 3 years. So the question, how much must be the deposit at the beginning of each month for the next 3 years now, so that the account, the future value of this annuity will be this one? So actually now 339,673 is the future value of an annuity, and I need to know the deposits of this annuity. Okay, so the future value, use the future value formula, 1 plus I to the power n. Now what is n? 3 years. Monthly, 3 times 12, that's 36, minus 1 over I. Now they will put it what? They will put the deposit at the beginning or at the end of each month? At the beginning of each month. So this is annuity due. So we need to multiply by 1 plus I. If you divide now this amount by all of this amount, you will find that R is 994.08. So this is the amount they need to deposit each month for 3 years to get what they need for their trip. Thank you very much. I hope you enjoyed this review. Have a nice time and study hard.